Hello everyone, welcome to this Huggingface workshop. Today we have with us Omar Sanseviero, who is a machine learning engineer at Huggingface. This is a part of ML Democratization Tour, and he'll be just giving you a brief introduction of Huggingface and a lot more. So, watch out. Handing over to you.
Awesome. Thanks. So, hi everyone. My name is Omar Sanseviero. As Parun mentioned, I am a ML engineer at Huggingface. The goal of today will be to give a brief introduction to Huggingface in a hands-on way. So I will talk a bit about the ecosystem. If you don't know what Huggingface is, don't worry. The prerequisite for this talk is just knowing Python, and that's pretty much it. So if you have a Colab account and a Hugging Face account, that will be better, but no worries, you can do it in 2 minutes or so. So let's just kick it with a brief story. So imagine that one day, maybe like you are in your first year of school, you want to work in your first machine learning project. And usually for doing an ML project, you need two big components. So you will need a model and the dataset you will use to train this model. And usually out there in the industry, obtaining this data for your specific task can be one of the most challenging parts of a successful ML project. So there are many models out there, but getting the data can be quite complicated. And then even if you have data and you train a model for this, you might not get the right results that you were expecting. Anyways, let's say that you were able to train a model that is performing well. So you were able to get to this point. But then doing the modeling is probably just a small part of the whole ML project. So there's this question of what do you want to do next? Maybe you will want to do a project in your school and you want to collaborate with others. So you might be wanting to share your models with other people. If you're in a company, you might want to share this with other members of your team. If you are a freelancer, you might want to show this to your customers. Or you might even, if you're a researcher, want to open source it so anyone else in the community can use it. Maybe you want to showcase your model in a presentation or conference. And when you want to do these kind of things, building a demo can be one of the most powerful ways of showcasing how your model does and what kind of problems you can solve with your model. So why demos? Demos allow you to do three things: easily present to a wide audience, increase the reproducibility of research, and finally, you are pretty much enabling diverse users, so people that are not necessarily ML engineers, to identify and debug failure points. And this is quite important because this enables having people that will be impacted by ML models that are not necessarily ML engineers or software engineers or computer scientists, but these people are able to try out the models. All right, and if you want to do this right now, until like 1-2 years ago, most people would say, yeah, let's do a HTML website, let's use JavaScript, let's use Flask, Svelte, React. So these are JavaScript, HTML, Python libraries to create a demo. But there are open source alternatives in Python, such as Gradio or Streamlit, which are two great open source libraries that allow you to build very, very nice interactive demos. And with demos, I will talk a bit more about what demos are concretely, and we will actually build one of these. Anyways, so once you have all of this, we can do things in a much simpler way than going out and getting the data and training a model from scratch and building a demo with HTML and JavaScript. If you used GitHub before, your approach probably was when doing a software engineering related project, you would go in GitHub, search for a repository that already implements the tools that solve some of the problems that you are having. So if you want to collaborate with your team, you will probably create a repository in GitHub and you will collaborate with others. And once you're ready and you have a project that you want to share with the others, you can open source so the whole ecosystem can leverage the work that you've done. And we actually can do exactly the same with machine learning. Why do we have hundreds of people training a model for exactly the same thing again and again? Sentiment analysis in Twitter. So sentiment analysis is the task in which, given a tweet or given a text, you will say if the sentiment is positive or negative. And there are many people that are doing this, and instead we could have a single model instead of each person training this model again and again and again. What if we could instead have a central platform or place through which people could collaborate, explore, and discover models and datasets? And that's where Huggingface comes in. The Huggingface Hub is a platform with over 30,000 models, 3,000 datasets, and people can easily collaborate, discover models, and have their collaborative ML workflows. And although the origins of Hugging Face were in the NLP domain, NLP is natural language processing, if you don't know, and it's the domain in machine learning and linguistics that is related to text. But nowadays, the hub has expanded to applications across other domains, speech, which is audio signals, vision, which is anything related to images, videos, but then even like fancier applications in time series, biochemistry, reinforcement learning, and who knows, the field is expanding quite quickly. And our goal is to democratize good machine learning, making it accessible to everyone, and give the ability to anyone to contribute to the greater goal of solving language. So that's where Hugging Face comes in. And how do we achieve this? First, we want to make ML accessible, and it's accessible means a couple of things. So it should be easy to access, easy to try things out, and we try to we share a lot of open source libraries that other people can use, and we also do open science. And open science means sharing all the science that we do. So if we train a model, we won't hold the models ourselves. We will open source them, we'll share the applications, and we will enable anyone else to use these models. Today, we'll take a look exclusively at the open source ecosystem at Hugging Face. We share all of our repos, our open source libraries in GitHub. These are our coding libraries. And here you can see a couple of them. You can see transformers, datasets, accelerate, Hugging Face Hub. Across these libraries, we have over 1,000 contributors. We have 60,000 stars. So these are very well validated libraries in the sense that the open source ecosystem has proven that they were interested in these applications. All right, so let's kick things off with the Hugging Face Hub. So the Hugging Face Hub is the place where you can find models. This screenshot is actually quite outdated. So this one says 14,000. 1 year ago, we had 6,000 models in Hugging Face Hub. Right now, we have over 30,000 models. And let's actually do this a bit more hands-on. So I will just go to the hf.co or huggingface.co website. And here at the top, you can click models. Here it will show you all the models that are in Hugging Face. So it's quite cool. At the left, you can find or filter by different things. So for example, if you're interested in PyTorch models or TensorFlow models, which are two different, very famous open source libraries to build ML models, you can do these kind of things. Or if you're interested in models for a specific language, you can filter. But anyways, we have talked a bit about models, so let's just jump directly to one and see what a model actually is. So there's a very famous model which is called GPT-2. Let's go to it. And what you see here is a model repository. So at the top, you can see a couple of filters. These filters are the same than the ones I was showing you before. So you have the text generation filter, which is the task that this model is trying to solve. It has some of the libraries in which this is implemented. It tells you which is the language, in this case, English, the license, and more tags. And all of these tags are quite helpful because they allow people to filter the models depending on what they are looking for. Then we have something that is called the model card. The model card is this whole text at the left that says things such as the model description, the intended use cases and limitations, how to use the model, which are the biases in the model. It also explains how this model was trained and more things. Why are model cards useful? Model cards really are a way of documenting a model. So they work as a mechanism through which people can document how a model works, which are the intended use cases, and how the model was trained. And it's very important because some of these models are quite costly to train. So it might take you weeks of a computer training this model or lots of data. So it's not something that anyone can do. But when you share these models, if you don't document them correctly, other people might not know what these models are doing. Something that is nice is that at the right, you can actually play directly with the model with these widgets that we call the inference widgets. So for example, here the sentence says, my name is Clara and I am. So when I click compute, it will take a bit and then it will generate a ML generated description, right? So the input was, my name is Clara and I am, and then everything else is something generated by a ML model. This task in machine learning is called text generation, which given an input, it will give more text. It will expand the initial text. And then there are other couple of things. For example, if you want to using transformers, you can click here, using transformers, which is an open source library, and it gives you a code snippet that you can just copy and paste. Going back to all the 30,000 models, we actually have models for quite a bit of different tasks. So we have NLP tasks. Summarization, for example, is giving a large text. The output of the model will be a summary, a smaller text of the same input. Text classification is similar to sentiment analysis. So sentiment analysis is actually an example of text classification. There's even translation models, which are able to translate from English to Spanish, English to German, English to Hindi. And then there are audio models. For example, there are audio classification models that allow people to do classification from audio files. So for example, here, you can put an audio file, and it will give you, in the example of this model classifies which is the language of the audio file. So you can put an audio file, and it will tell you this is an English recording. And again, this is not limited just to audio or NLP. This is also expanded to image. So for example, image classification, object detection, image segmentation, and even things outside this normal, more common fields. So for example, structured data classification, which would be tabular data, so tables, time series, and other kinds of data. So for example, let's say that I would be interested in text classification in Spanish. So you can also click here. We have support for over 180 languages. I can click in Spanish, and you'll find that there are a couple of models right here. And something that is cool is that you can see how many downloads these models have. You can see how many likes the models have. So I can go to this model, or I could go, let me go to, I think this one is quite good. And you can try it out directly in the browser. And it's very nice because you can just go out there and find any of the models shared by the community. All right. Let me go to the next one. So the Huggingface Hub has by now over 30,000 public models. So these are models available to anyone out there. We have models for 20 different tasks. And although we have support for Huggingface transformers, which is an open source library created by us, we also have integrations with all the over 20 libraries in the open source ecosystem. So these names might not, you might not know them, but for example, there's a library called SpeechBrain for audio, Spacey for NLP is quite famous, and then even like higher level libraries such as, or more well-known libraries such as TensorFlow or PyTorch. We have integrations with these libraries that enable anyone in the community with one command to upload their models to the hub. And we have support for over 180 languages. But there's one question here, which is, what exactly is a model, right? So previously we were talking about GPT-2, and we have all of this, but what is a model? And you have this tab, which is files and versions. And this shows you all of the files that are in this repository. And that's a keyword here, is that at Hugging Face, all the repos are repositories. So if you've used GitHub before, here it's very similar. These are Git-based workflows. So people can do the same things they are used to. So they can do git add, git commit, git push, and they get version control. Version control means that you get the history of your repository. So here there's this history link, which tells you all the history of this repository. And this is quite good because this allows you to go back to a previous version, or if you need to have versioning of the model, if you are retraining the model every week, this allows you to have models at different versions. And it gives you other information. For example, a config JSON provides different information about the architecture of the model. Or previously we were seeing the model card, but the model card under the hood was just a markdown file. So markdown is a very simple syntax to have like titles, links, and all of this text that you're seeing here is exactly the same as this nice text that you're seeing here, the model card. And all of this is open source, so that means that anyone can go here and can download these models. And depending on the license, of course, they can use these models, right? So we already saw model cards, we already saw version control, we already saw interactive widgets, but we actually have a couple of other interesting features. So the first one I would like to show you is called Tensorboard hosting. So if you don't know Tensorboard, Tensorboard is a tool from Google that allows people to create logs of the model during training. And it then gives you a nice web interface that allows you to see out like the metrics and how the model was performing during training. So for example, in the moment in Huggingface in which people submit Tensorboard logs, they automatically get this freely hosted Tensorboard instance that in this case, for example, it gives you things such as the loss. For example, the loss is interesting. So you can see how the loss of the model was decreasing, which is usually the goal during the training of these models. Another thing I would like to show you is metric reporting. So this is very cool from the perspective of scientific reproducibility, is that people are able to report their own metrics. So you can get links here that say which are the evaluation results. For example, this one is the word error rate on Common Voice 6.1 is this. Word error rate is a metric, don't worry too much about it, but it's just a number that tells you how well a model is doing. So here you can see that the model is performing with these results in this dataset, which is called Common Voice. Again, don't worry too much about the concrete names of these things. The important thing is that there is a mechanism through which people can report how well their models are performing, and it allows people to compare models. So let's go to another example. You can go here to eval results at the bottom left, and this will give you a filter to find all of the models that have the evaluation results. Let's go to this other one, and again here at the top right, at the bottom right, sorry, you can see the evaluation results, and there's a view leaderboard link that links to Papers with Code, which is a platform from Facebook that allows you to compare all the models that were evaluated on this dataset. And it gives you like a nice leaderboard, so you can see which is the accuracy of all of these models. And if you click here, you will go back and find which is the corresponding model in Hugging Face for this particular metric. All right. And as I was telling you before, we are not limited to transformers. You can actually use Hugging Face with any library that you have. So if you are a Keras user, you can use Keras. If you are a PyTorch user, you can use PyTorch. If you are a SpeechBrain user, if you are a Team user, so we have a lot of integrations. If you use scikit-learn as well, you can easily upload the models. It takes a couple of minutes, and then you can download the models again. So the usual workflow is to go to the hub and find a model for a task. And you can just pick this model and use it. But there is something very interesting in NLP and now also in computer vision and in audio, which is called transfer learning. And I won't jump too deep into this because it's it's something that could lead for 10 minutes of discussion. But the high-level idea here is that you can pick a model that has a high-level statistical understanding of a language. So for example, this could be a model that was trained for medical text in Spanish. And then you can do something called fine-tuning to modify this model for a particular task. So the original large model, which was very expensive to train, it works just to understand the Spanish language in the biomedical field. And with fine-tuning, you will get as an output a new model that will be able to, I don't know, maybe classify or maybe generate text or different things. It might be able to write summaries, for example, of biomedical data. So the workflow here is that you usually go to the hub, you find a pre-trained model for this. You also need to get a data set, and you will train this model, or you will fine-tune this model using this data set. The output of this will be a new model, and what most people do is that they can go to the hub and then they can upload the model again. So it's nice, you go to the hub, you find a model, you fine-tune it, and the result you share with the community. There is this missing component, which is datasets. And the hub has three verticals. The first one was models, but actually the second one is datasets. So in the Huggingface Hub, we actually have datasets as well. We have over 2,000 datasets by now. We have datasets mostly for NLP, but growingly in the computer vision and audio domains. So for example, Common Voice, which is a very famous audio dataset, you can also find it in the Huggingface Hub. Actually, let me just go to the hub and show you. So here at the top, you can click datasets. And at the left, you can filter again by language, by the size of the dataset, by which is the task category. You can click things such as Clue. Clue is a very famous dataset, and you can even directly see a slice of the dataset in the browser. So without needing to download the dataset locally, you can see and explore this dataset up there in the browser. And you can even see different splits. So for example, in machine learning, you usually have a training split and a validation or test split. You can explore both of these. And same as with models, we have a dataset card. A dataset card is also documentation for the dataset. So it gives you a summary of the dataset. It gives you a dataset structure. This dataset is a bit more complex, maybe, but it also gives you information such as dataset curation, which is the source data, which is the social impact of the dataset, and citation information as well. Something that is cool is that at the right, you can see which are the models that were trained or fine-tuned. So I can go here, I can click this, and I can see that this model was actually trained with a Glue dataset. So it gives you a linking between datasets and models, and it's very nice because here I can see the 200 models that were trained with this dataset. So, all right, so you have datasets, but then how do you access them, right? So you have datasets for over 2,000 datasets by now, for over 400 languages and dialects. But we also have a library called Datasets. So you do pip install datasets. It's a Python library. And with just one line of code, you can load any dataset. If the dataset is huge, we have something called streaming. So huge dataset means that the dataset is so big that it won't fit in your computer. And if you need to train a model, you will need to be loading this dataset. So we provide mechanisms that allow you to load these datasets without impacting you. And just to give you one example, here at the top right, there is this use in the dataset library. And it gives you a code snippet. It's really just 2 lines of code that show you how to load this dataset. So it's just doing from datasets import load dataset, and then dataset equals load dataset. So as you can see, it's actually quite simple. So we provide the mechanisms through which people can share their models, their datasets, and then mechanisms through which people can easily access these datasets and use them in their machine learning workflows. All right, so we got here, we got a model, we got a dataset, we were able to fine-tune a model and share our model with the community. So yeah, I guess we are done, no? And then you realize that although you have a nice model, you were a bit stuck. You want to share it with the community, or you want to put it in your portfolio, in your CV, your resume, your LinkedIn, Twitter, I don't know. And then you realize that there is no simple way to showcase this model. So you might be able to create a Colab. Colab, if you've never used it before, it's a Jupyter notebook hosted on the cloud that allows people to just run Python code directly in the browser. And you can share that, but then you're expecting people to open this and run all of these cells of code. So you probably want to build a demo, which is what we were talking at the beginning. But to build a demo, then you might be a bit worried that you need to learn like front-end technologies and you don't even know where to start. I was talking about demos, and this is a nice example of interactive demo. So this demo is a news summarizer demo. At the left, people can put a URL. They can click submit. And then at the right, it will give you a summary of the news in that article. And at the bottom, there are different examples that people can click in. And yeah. And these demos actually have been quite impactful. These kinds of demos have been able to get to trending places, so they get to social media, but it's not about getting to social media. The cool thing here is that non-ML engineer people, so people that might not know much about ML engineering, are able to create or able to interact with these ML models. And it's very cool because here we are lowering the barrier for anyone that has a browser to try out these demos. So until recently, or even a bit now, if you want to start using ML, you need to be a ML engineering or a software engineer. But now, even if we don't expect anyone to be creating ML models, by creating these kinds of interactive demos, anyone who has a browser can, or any graphic user interface, they can actually start playing with these models. So today I'm going to talk a bit about Gradio. Gradio is a very cool open source library that allows people to create nice interactive interfaces for their ML models. And here at the left, you see 5 lines of code, but this is pretty much everything that matters. First line of code, we are doing an import. So import is simply importing that library called Gradio. Then we create a Gradio interface. And the Gradio interface at its core only has 3 key components. It has, let's skip the first one. It has the inputs. So you specify which are the inputs of your demo. So it might be text, it might be image, it might be audio, it might be something more fancy. It might be even multiple text fields, right? And then you specify an output. And an output can be, again, image, a text, a label, different things. You can see this demo at the top right. So at the left, you have the input, which is an image. And at the right, you have the output of the model, which is the label. And then in the interface, the first line is which is classified skin image, is the prediction function. The prediction function or the inference function is just a function, a method that takes some input and has some output. So it will receive the image and it will output the label. And finally, the last line of code, which is app.launch, that will pretty much just launch the demo. And this works anywhere. So if you're doing it locally in the terminal, it works. If you're using a Jupyter notebook or a Colab notebook, that also works. So let me show you an example. So right now, here I am in Colab, and I imported a couple of libraries. I imported transformers, Gradio, and SentencePiece. Don't worry about about these specific libraries. First, I'm just going to run this cell of code, and I'm going to show you the demo, and then I'm going to walk you through the actual code. Right? So again, I'm directly in a Colab notebook, and it gives me this demo that says interactive demo, Helsinki NLP, English to Spanish translation. All right, so this is a model or a demo that will show me how to translate text from English to Spanish. So here at the bottom, there are a couple of interactive examples. So let me try, hello, my name is Omar, and I will click submit. So after 0.7 seconds, I got this output which says, hola, mi nombre es Omar, which is exactly the same, but in Spanish. And I can try other sentences. All right, so the demo works well. Let's go and see which is the code for this demo. So let's first just look at the interface. So first we have a title which says Interactive Demo Helsinki NLP English to Spanish translation, which is this same text. We have a predict function, which is exactly the same as what we were seeing here. We have the inputs. So the input here is just a text box, which says, I like this workshop. It can be anything, right? I can write here anything. And I also say that I want this to be 3 lines of text. And the output is also text, so it's quite simple. The interface also specifies the title, and finally the examples. And the examples are these 2 examples that you have here at the bottom. All right. Then let's go to this predict. And predict can be from any library that you have. So if you're a scikit-learn user, this can be a scikit-learn demo. If you're a TensorFlow user, this can be TensorFlow. So this can be any library that you have. In this case, I'm going to use transformers, but I don't want to discuss too much about the syntax. But pretty much what I'm doing here is that I'm creating a translation pipeline using a model. So translation is the task of translating from one language, so Spanish or English in this case, to another language, which is Spanish. And in the translation pipeline, you can specify a model. So here I'm saying I want to use the Helsinki NLP Opus MT EN ES. So where does this model come from? So you can actually go to Huggingface. So you can just search this, and you will find this model directly in Huggingface. So this is a model hosted in the Huggingface Hub, which here again we have the model card here, so we know that it goes from English to Spanish, and it has a couple of metrics here. But this institute, the Helsinki NLP group, has a couple of, it has 1,300 models, so over 1,000 models, most of them being translation models, and these are pairwise translation, and you can find from English to Spanish, English to Portuguese, but also Portuguese to Spanish, probably Spanish to Hindi. There are hundreds of models to explore, and you can use any of these over 1,000 models to just go here and translate. So this line will be just downloading the model and creating the pipeline. And then you can do very simple things such as pipe, which is the pipeline, and use it as a function. So you can specify any text. And then what comes next, don't worry too much, but the idea here is that this line of code is just making a translation. So this function, the predict function, is the inference function. So it takes an input, which was the text, which was the input here, and it gives you an output, which is a new text. So input, output, and prediction are the only 3 components in Gradio, and it allows you to build very interactive demos with 10 lines of code, and it's quite simple to use. All right, so we were able to build an ML demo, which is very nice, but this is still in Colab, right? So we are still expecting people to actually click through the code and run it. So right now, we don't have an easy way to share with the community, or if you want to work in a team, there is no easy way right now. So you can go to Hugging Face Spaces. Here is a link. If you're in Hugging Face, you can also just go to Spaces here at the top. And Spaces is an easy way to create and host awesome ML demos in just a couple of minutes. And these demos are quite powerful, so you can build your portfolio. And once you start applying to your to any company, you have a portfolio of ML projects. You can work collaboratively, so you can be in a team creating the same demo. So if this is for a university project or for a company project, you can work together. And finally, it's an easy way to showcase the models in a very quick way. So we've seen many people, students especially, using this as project presentations at the end of the semester. And what is interesting here is that setting up the demo is quite easy. So if you already have a model for this, setting up the demo will take 1 hour, 2 hour stops. If you already know how to do it, it takes like 5 to 10 minutes, really. And you can use Streamlit, you can use Gradio, which are both Python libraries. You can also use actually raw HTML if that's something that you want. So it's quite flexible for whatever you need. And if you go to Spaces, you will see that there are a couple of thousands of spaces, and it's quite cool because we launched this 4 months ago, and by now we already have over 2,000 spaces shared by the community. But yeah, in any case, let's say that we have this demo and you want to share it with the community, right? So this is a Colab that is something that is just in a Colab and people need to run the code. So you can click your profile picture at the top right. You can click new space, and here you can see that you can click you can configure your space, right? So create your test. This is the name I will put. You can specify a license. You can specify which is the SDK that you want to use. So I will use Gradio. You can make this demo public or private. So if you make it private, usually we do everything public, but if people want to do it private and then once it's ready, they change to public, that's also fine. And you can go and create the space. So as I was telling you before, everything in Hugging Face is based in Git repos. So you can actually go locally and do git clone and this link. You can work locally and then you can do git add, git commit, git push. But you can also just work directly here. There are some instructions here, and I will just do it directly here in the browser. So what you can do is create a file called app.py, and I will just go here, copy this same code, and paste it here. You can then write a commit message, create initial demo, and commit. It will take a couple of seconds because the first time it's building, and you can go to app. Let's wait 5 more seconds. And in this case, I'm getting an error because it's telling me that there is no module named transformers. You can also click here, the C logs, and you will see extended logs. In this case, the error was quite simple, but this is also quite useful. So what's going on? So here in the Colab at the top, I was actually installing a couple of libraries, but here we don't have that. So what you can do is create a library file, which is called requirements file. And you can specify line by line some dependencies that you might want to have in your repository. So I want to have transformers, Gradio, sentence piece, and PyTorch. Once you click commit, again, it will automatically kick off the rebuild, and it will take this time a bit longer because it's building, it's installing all of these things. So you can click see logs, and this is not super important, but here you can see that things are getting installed right now. Under the hood, this is using something called Docker. This is installing a couple of things, but in your case, you don't need to worry about how this works under the hood, right? You can just specify the requirements, wait a bit, and see how things look like, right? So this is taking a bit. So while this is building, let me show you a couple of demos that I like quite a bit, right? Actually, let's see if this works. Yeah, so this is the exact same demo that I was showing you in the Colab, but now this is in a link that anyone can go and anyone can access. So it's completely open to anyone out there. So I can click here, hello, my name is Omar. I can click submit, and here you have the output. All right. Yeah, so let me show you a couple of additional demos that I like quite a bit. This is from Microsoft. This is Wave LM. So here you can put 2 audio files. So these are voice recordings. And when you click submit, it will tell you if this is the same person speaking in the 2 audio files or if these are 2 different persons. So for example, this one are 2 different speakers. So in this case, it tells you the speakers are not that similar, you shall not pass. Right, I think this one is broken. So this one allows you to create a text, an oil painting of a corgi. And it takes like 20 to 30 seconds, and it will automatically generate like a ML generated image, which is quite cool. So let me just jump to the second one, which is ancient Greek syntax analyzer. So you specify a model, you give some ancient Greek text, and it will give you things such as this is the noun, this is a determinant, this is a verb, and it will give you the kind of relationships between these different components. And it even gives you like some trivia. I'm not an expert in linguistics, but this is like a very useful tool for linguists. and even like a table view. Right, so going back to the previous demo, after 12 seconds, it generated a oil painting of a corgi. So, and then you can even like take a screenshot here, and it will automatically download, and you can try things locally if that's something you want later to share in social media, for example, and whatnot. One application also is in the medical domain. So, for example, here in this image, you can click submit, and it will give you a semantic segmentation to identify the left ventricle in echocardiogram images. So yeah, this is quite cool. It will give you the left ventricle echocardiogram. And yeah, these are the demos I wanted to show you. These are some of the ones I like quite a bit. And let me present again. So out there are already a couple of thousands of models built by the community. So these are demos that are created by people. They share them with the community, and everything is open source. You can build your portfolio, craft collaboratively, showcase your work. And if you prefer to collaborate through GitHub, there are GitHub Actions workflows that allow you to simply synchronize your space with GitHub, so you have the same code both in GitHub and in Huggingface spaces. So just to conclude a bit, spaces, models, and datasets, all of them have in common that they are Git-based repositories. They are optimized for machine learning. So in machine learning, one of the challenges is that the files can be quite large. They can weigh gigabytes, or datasets can be terabytes or even more. So everything here is optimized for ML workflows. And everything is very well integrated in the ML ecosystem. So we have integrations with many libraries, many people are using us, and we try to collaborate with as much, we try to collaborate as much as we can. So anyways, this was everything I wanted to show you for today. Thank you very much. And I don't know if there are any questions that people might have.
Hi, we have a question from Amish. What type of backend is used in Gradio?
Good question. As far as I know, this is using Fast API. It was using Flask until recently, but it's using Flask API. In any case, this is not something that, as a user, you need to be concerned about. Gradio manages everything under the hood for you. And by the way, with Spaces, we've seen people creating backends with other things. So we've seen people using directly Fast API or directly Flask or directly like other like backend systems. And you can even do like raw HTML things. So yeah.
Yeah, like we can wait. If anybody is having a question, they can put it in comment section. We have one question from Gunjan. Can we upload large models datasets on Spaces repo? Is there a limit for free tier?
Yeah, so we have these three verticals, right? So if you want to upload a model, you would create a model repo. So you would click new model, and you will upload this model in a model repo. If you want a dataset, you would have a dataset repo, or if you want just a demo, you would have a space demo. In terms of size, there is no limit. I mean, we can go to GPT from a community called Eleuter AI. And you can see that their files can be, their models are 22 gigabytes. That means they are quite large. And no, there's no limit in free tier. People can upload as many models, datasets, and spaces as they want. And yeah. Of course, like if you want to upload like something crazy, just send us an email so we can work on you and see if that's like find the right way to do it. But in general, like people can create as many repositories, spaces, and datasets as they want. There is no limit on this.
Yeah, Mahdi asked whether Hugging Face is working in some research area where he could contribute for his thesis, possibly pursuing his PhD.
I mean, we have role openings for research interns, so feel free to apply if you're interested in this. Apart from this, if you're interested in contributing to some research, there are communities such as Hello.ai. Uh, it's it's the name is here actually, Hello.ai, which are doing quite a bit of public research. It's a Discord server at the end with thousands of people, and you can, like, if you are interested in contributing, you can go here and do it right now. But you can also apply to Hugging Face for a research engineer or a researcher, a research scientist internships if you want.
Yeah, there's one more question. Is Hugging Face working on a new area of research that you could like possibly tell us?
Yeah, so we are doing research in quite a bit of topics. We are doing research in the ethics and data measurement side. So, for example, and one good place to go, like if you're interested in more information, is that you can go to the blog, and there you can see some of the things that we have been doing. So, for example, we have been investing quite a bit in the audio speech domain. We have been integrating other libraries, but you can go here and click research. And for example, you can see the work we have been doing with in the speech side. We have CodeParrot. CodeParrot is a cool project that is to create a model that is able to, open source model that is able to generate code. So that's something that we also have. This is the data measurements tool, which is a tool in the topic of ethics of a model and good practices for dataset documentation. And a very cool project actually was this one, deep learning over the internet. This was from 7-8 months ago for the NeurIPS. And here the idea was that when you want to train a model, it usually involves significant amount of compute power, uh, which means that people or communities that don't have computational resources, so they don't have GPUs or TPUs, they are not able to train these models. And this project, which was a collaboration with Yandex, it consisted on having distributed training. That meant that many people from a Bengali community in a Discord server were able to, each of them, give a bit of their own compute power to train a model in a distributed fashion. So we had, let's see, 40 different people. So 40 people were giving a bit of compute power, and we were in a central place training this model. It was quite interesting. So yeah, in terms of research, Hugging Face is doing its own research in many areas. We actually have a very large research organization. And you can go here and explore a bit the different research related things we have been doing.
I think like we don't have any question. There's a question from Varun. Is there any way to partially fine tune Hugging Face models?
Yeah, so in CNNs, what you do usually is that you pick a pre-trained model, you remove the head, and you freeze, right? The concept of transfer learning is exactly the same for NLP. So you pick a large model, you remove the head. In NLP, you don't freeze the weights, so that's the only difference. And then you add a new head depending on the task. So if you're interested in doing text classification, you add one type of head. If you're interested in doing token classification, which is to identify, for example, entities. So if you want to identify there is a company in this sentence, or there is a person or a location in this sentence, there are different kinds of heads. But the concept at the end is exactly the same. You pick a pre-trained model, you remove the head, and you add a new head. That's why transformers are quite powerful, because they were able to introduce transfer learning to NLP. So previously, the concept of transfer learning was extremely powerful in vision, but there was no transfer learning in NLP. Transformers were able to achieve this, and that's why they have been quite successful, although they were published 5 years ago. If you're interested more in this topic, you can click here this burger icon at the top right, and we have a free open course. And this course actually teaches you everything about this. So it gives you like examples, code. It gives you explanations of everything. And here is actually like the explanation of how transfer learning works for NLP. So this is a great resource. It's free again, so you just click here. It has a lot of content material, so I would really suggest you to go there and try out things. I hope this helps with the question.
Yeah, thanks a lot. Like we can wait for a minute. If anyone is having a question, they can put it in the comment section, or if not, like we can end the live stream. So it seems like we do not have any questions. So we can end the live stream. Thanks a lot, Omar. Like it was very informative session, and like everybody learned a lot from it. And like we hope like we can have something more like it in the future. Thanks a lot.
Yeah, thank you very much for the invitation, and thanks everyone for joining. This was great.
And yeah, thanks a lot again to everyone for joining. And like we would be having our last talk tomorrow by Pranav. So like hopefully you will join it too. Thanks a lot.